The drilling business isn't getting any easier. Wells need to be drilled faster, cleaner, with fewer problems, and at the same time with the added pressure of lowering costs, even in the harshest conditions. And there are environmental concerns to deal with as well. Where will it all end? Here and now. Drilling with MMH-based drilling fluid systems from the Dow Chemical Company will make drilling easier because the MMH system is superior to conventional systems in use. First, MMH-based fluids are truly unique. They are low solids aqueous drilling fluids that use cationic mixed metal hydroxides to extend bentonite, attapulgite, or sepiolite in both freshwater or brine. One of the properties that makes MMH drilling fluids unique is its gel structure. MMH crystals are cationic sheet-like platelets that, when dispersed, are considerably smaller than an average bentonite, attapulgite, or sepiolite particle. The combination of positive charged MMH crystals and small particle size causes the crystals to interact with the clay particles through an ion exchange mechanism, resulting in the unique MMH gel structure that is capable of remarkable solid suspension. In practice, this is what happens. These two samples test the comparative suspension abilities of two fluid systems. The sample on the left contains 5 pounds per barrel of bentonite extended with MMH at 0.75 pounds per barrel. The sample on the right is a standard fluid containing water and 20 pounds per barrel of sodium bentonite. When both samples are agitated, the gravel in the standard system settles to the bottom, but the gravel in the sample extended with MMH remains suspended. In undisturbed samples, the gravel has remained suspended for more than 2 years. Yet when the sample is tilted, the MMH-based system flows easily, carrying the suspended gravel with it. Next, let's compare MMH fluids to polymer systems. You know that polymers tend to degrade at the high shear rates encountered at the bit. This results in the loss of important fluid properties. MMH is not a polymer. Incorporating MMH into a drilling fluid system provides a low solid shear thinning fluid that will not degrade at high shear rates. In addition, MMH-based fluids will remain stable at temperatures up to 350 degrees Fahrenheit in bentonite systems and 450 degrees Fahrenheit in attapulgite systems. The mechanical and thermal stability of MMH-based fluids requires fewer adjustments, which can save drilling time and money. This next lab test compares the suspension properties of MMH-based fluids with other systems containing 3 leading polymers used to build viscosity and increase suspension and carrying capacity of the mud. Sample W contains bentonite extended with MMH. Sample X contains xanthan gum. Sample Y contains polyacrylamide, and sample Z contains carboxymethylcellulose. When the test unit is inverted, the ability to keep the ball suspended demonstrates the ability to keep cuttings suspended. In sample Z, the carboxymethylcellulose, the ball sinks rapidly. The ball in sample Y, the polyacrylamide, also sinks quickly. Next, the ball in sample X, the xanthan gum, also sinks. But the ball in sample W, containing MMH-based fluid, remains suspended in the fluid indefinitely, demonstrating that MMH-based systems outperform the 3 leading polymers. In this last demonstration, a 4-foot plastic tube with a 2-inch interior diameter is used to closely simulate horizontal drilling conditions using a water-based system as a drilling fluid. When the pump is operating at normal capacity, the sand or simulated cuttings are carried along at the bottom of the pipe. But when additional sand is added to the system to simulate cuttings and solids in the well hole, a bed of material builds up. When the pipe becomes blocked, the water above the bed goes into turbulent flow. At this point, the bed won't increase unless the flow is decreased. But if the pump is turned off and the flow is stopped, all the cuttings fall to the bottom of the pipe. But in this separate MMH system, and with the pump operating at normal flow, the cuttings remain suspended. While the cuttings near the pipe wall move more slowly, all the cuttings continue to move and no bed is built up. This is true even when more cuttings are added and the flow rate is reduced. And most importantly, when the flow rate has been completely stopped, the fluid instantly becomes a gel, holding the cuttings suspended. No matter how long the pump is stopped, the flow resumes easily without any pressure surges. These lab tests dramatically illustrate the unique properties of MMH-based fluids. And actual field experience in numerous wells drilled under difficult and varying conditions has provided remarkable results as well. In these wells, operators found that cuttings stayed suspended with no hole fill during long bit trips. When mud pumps were restarted, cuttings discharge was immediate and didn't vary. Bottoms up could not be detected by an increase in cuttings volume, indicating that even heavy cuttings stayed suspended. Even the heavy metal cuttings from milling jobs are easily removed. Obviously, the greatest benefit of MMH-based systems' unique rheology is the excellent hole cleaning ability it provides. Solids are easily carried and suspended better than in high viscosity systems, and it is achieved at very low flow rates. But that's not all. MMH-based fluids also offer other important benefits. MMH muds provide a remarkable ability to protect boreholes by inhibiting the swelling and dispersion of smectitic shales. The MMH-based fluids coat the shales by creating a film of slow-moving fluid near the edges of the shales. Sloughing and shelving problems are minimized, and well bores are protected. As dramatically shown in these actual caliper logs from 2 offset wells, the MMH-based fluids demonstrate a remarkable ability to drill holes nearer to gauge through various formations. Closer to gauge boreholes can reduce expensive and time-consuming logging costs, as well as substantially lower cementing and casing costs. Chemical and additive costs are also reduced because MMH-based muds are resistant to common contaminants such as mixed brines, calcium, hydrogen sulfide, carbonates, and others. This means significant time savings by minimizing adjustments to fluid rheology during drilling operations. Bit costs are reduced too because MMH muds are so effective in removing cuttings from the bottom of the hole. Wear is reduced on drill bits, prolonging their life. On difficult wells where bit life is a problem, MMH-based fluids can reduce bit consumption by as much as 30%. And then there's the environment to consider. MMH-based fluids are low in toxicity and meet tough EPA requirements. In fact, MMH-based fluids have been approved by the EPA for offshore drilling. MMH muds are excellent for use in environmentally sensitive areas, whether onshore or offshore, where expenditures for cleanup and handling precautions can be significant. The bottom line in any drilling operation is total well cost. And MMH-based drilling systems can help minimize your costs and maximize your drilling performance. MMH drilling fluids are cost-effective. They save time and money by allowing you to drill faster and with less trouble time. And they reduce problems caused by active shales and fluid contaminations. If you want to drill wells faster, cleaner, with fewer problems, and at reduced cost, even in the harshest conditions, it's time for you to consider a new way of doing business. MMH-based drilling systems for your next well.